Okay, so a few things about your lab. For question number 4, remember that your initial temperature is going to be the average of the temperature of your hydrochloric acid solution and the temperature of your sodium hydroxide solution, because you had 2 solutions. So that's going to be your initial temperature. Okay, so then for number 7, you have to calculate the moles of sodium hydroxide. And you have that 2 different times. So let's say that in your first reaction, so in reaction number 1, you use 2.06 grams of sodium hydroxide. This is the easy one, right? So we're just going to take the fact 2.06 grams of sodium hydroxide, and we're going to multiply that by 39.99 grams of sodium hydroxide in 1 mole of sodium hydroxide. And that's going to give us our number of moles of sodium hydroxide in our reaction. In reaction number 2, though, you used a solution of sodium hydroxide. So let's say that you used 50.4 milliliters of sodium hydroxide. And you know that your sodium hydroxide solution was 1.0 molar sodium hydroxide. So you're going to use this conversion factor, and you're going to start with the 50.4 milliliters, and you're going to say, okay, well, I know that there are 1,000 milliliters in 1 liter. So now we've converted from milliliters to liter. And then we're going to use the fact that this tells me that I have 1.0 moles of sodium hydroxide in 1 liter of sodium hydroxide. So in my first reaction, I'm going to have pretty similar amount. I'm going to have in this reaction 0.0504, but I'm going to have to drop that 4 because I only have 2 significant figures, moles of sodium hydroxide. And when we do the math, we're going to find that we have a very similar amount of sodium hydroxide in this reaction. So that's how we're going to solve on number 7, and you're going to repeat this process with the mass for reaction number 3. Okay, so let's talk about number 6. Sorry, I jumped ahead. So number 6, it asks you to determine the heat released by your reaction. So you're going to use Q equals mass times specific heat times change in temperature. Now, this is the mass of your water. You're going to have to use 1.0 grams per 1.0 milliliters in order to figure out your mass of water. This is the specific heat of water, so this is going to be 4.184 joules per gram degree Celsius. And then this is going to be the change in temperature of your solution, so that's going to be your final temperature minus your initial temperature. So let's say that in this reaction you had 100.0 milliliters of water. We're going to change that milliliters to grams because they're the same thing in this particular situation, times 4.184 joules per gram degree Celsius. And then our change in temperature, let's say that you went from 20.4 to 25.8. So we're going to be left with an answer that's in joules. Okay, and that's going to be how much energy is released by that reaction, how much heat is released by that reaction. Okay, and this problem, which is number 6, leads us right into problem number 8, because you will have figured out how much sodium hydroxide you used. And for number 8, it's asking you to calculate the delta H of the reaction. Now remember, the delta H reaction is always expressed in kilojoules or joules per mole. Okay, but our Q is going to give us a result in joules. So in order to get from Q to delta H, we need to say that delta H of the reaction is equal to the heat released by the reaction, or the Q that you calculated here, divided by the moles of sodium hydroxide. Okay, so that calculation, once you have this answer, and you have the answer from number 7 that gives you the number of moles, you're going to be able to figure out number 8. And you're going to do that for each one of your reactions. Okay, so last two that we might have some questions about would be number 11. And in terms of calculating the delta H directly, that's going to be when you determine delta H of the reaction number 3. That's calculating delta H directly. And calculating delta H indirectly is going to give you, that's how you're going to take delta H of reaction 1 plus delta H of reaction 2. Now we know that in theory these should equal delta H of reaction 3. But this is our indirect method and this is our direct method. And then number 12, this is the problem that this whole lab builds toward. And it asks you, could the janitor have burned himself with this process? So you first need to determine from the information that's given the number of moles of sodium hydroxide that the janitor was working with. And you also need to determine the moles of hydrochloric acid that the janitor was working with. And you need to figure out which one of those is the limiting reactant. This is a 1-to-1 reaction. So whichever one you have fewer moles of, that is your limiting reactant. Then you need to take that limiting reactant and you're going to plug it into your delta H reaction, and you're going to say, okay, the delta H of the reaction, and we're going to use delta H from reaction 3, times the moles of sodium hydroxide is going to equal the heat that was released when the janitor made the mistake. Okay, and now I want you to use Q equals mass times specific heat times change in temperature. Again, the mass of the water or of the solution, specific heat of water. And now you're going to be able to solve for change in temperature. And once you do, you know that the change in temperature is equal to the final temperature minus the initial temperature. And you need to figure out what that final temperature is going to be. And once you figure out the final temperature, you'll know whether or not the janitor would have burned himself. And you can answer that question. All right, guys, I hope this helped. I hope you enjoyed your snow day, and I'll see you tomorrow.